Welcome, everyone. Today we're going to be talking about Tanzu AI Solutions Essentials, what you need to get up and running. I'm John Dwyer, and I work in the Tanzu division in product management focused on our AI. So I'm responsible for multiple products in this space, and I'm joined by Adib.
Hi, folks. I'm Adib Saikali. I'm one of the leading engineers working on this stuff with John.
All right, so just level setting. I'm sure you've been to a session already. Check out the disclaimer. So today we're going to get started. One of the things we wanted to do was start out just by level setting with everyone. AI 101, buzzwords. There's a lot going on, and we wanted to make sure that we kind of all have the language down pat before we get started. Then we want to look at implementing an AI platform. And we have an opinion that you shouldn't do it the hard way. And then we'll go into a demo and see what it looks like. Oh yeah, I forgot I had this. All right, so first, what's going on in the market? The market that's pretty much every time you turn on the TV, all you hear about is AI. Every vendor down there has AI. Great shirt up front with the AI on it. But what's been interesting, we're working with customers on this, is just the way that they're looking at it and how fast they're reacting to what's going on in the market. So I love this statistic that we pulled. 90% of leaders are making substantial investments in generative AI, but the bottom two are what's interesting. It's so big that they're creating new budget lines for it. They're reallocating funds. I'll give you a great example of that, us at Broadcom. So there was a mandate that came out is how do we can get coding assistance for our developers. This wasn't in the plan. They figured out how to get it in the plan. So we're working through that now and rolling it out in the company. So we've got this opinion that AI agents are, the wave of 2025. They really started in 2024. But you can ride that wave with a combination of the Tanzu platform that we build and deliver and Spring. All right, so getting started, we're going to do an intro to artificial intelligence, the land of natural language processing and confusing terms. What's interesting is this is a combination of bringing different groups together, right? You had data scientists, and now you're bringing in developers, and sometimes they use words that mean the same thing, but they think they are completely different. So first question for the room, is Gen AI the same as general artificial intelligence? Correct. False. It's not, right? And this is an example. We have to be careful about how we position the words. And this is also a great example. This is a terrible graphic. When I created this, the marketing team that looks at all of our presentations were like, you have a terrible graphic that has a transparent background in it. I asked the AI to, the one specifically in the Google tools, to create me a stamp that said false. And it created this because, and I specifically said, with a transparent background. But because this model is trained on everything on the internet, and every time you search for on Google for a transparent background image to stick in your slide, they all look like this. And so that's what the model thinks a transparent background is. Now, this is a great example of why we have to be careful with implementing AI. So these models are becoming incredibly powerful, but at the same time, kind of stupid. So unless you provide your data and you provide the right set of guardrails around it, you're going to get varying answers like this. So coming back to the confusing terms of generative AI. So generative AI and Gen AI. So the first thing, the general artificial intelligence. This is people usually misspeaking on the internet. They really mean artificial general intelligence, or AGI, right? And so we came up with a simple way to remember this. So first, generative AI, what is it? It's when you take things I know about, the model, right? It is trained on a broad set of data, and it combines it with something you asked about, and you get something new, all right? Now, what is AGI? Well, AGI is what we normally think of as like Skynet and the Terminator, right? So it's, and that one got flagged and removed. They let SpongeBob through, but they wouldn't let the Skynet logo through. So artificial general intelligence is this concept that AI systems can learn and understand like humans. All right, so this has been around for a while. Why is it suddenly important now? So artificial intelligence started all the way back in 1956, and then we get to machine learning, so we're training systems on data. And then in 2012, we get deep learning, so we mixed neural networks into the machine learning. And then we get to deep learning, and then we get to general artificial intelligence, right? So what really happened here, and then 2024 we get agentic AI. These are kind of all subgroups of the same thing, right? We're getting better at using the technology that was founded in 1956. But a lot of times in the industry, it's what happens between the lines that's important, right? Like in 1996 when Microsoft gave us Clippy, that was a really important time. The reason is that, was that really the first agent? Maybe. Not really, because it was just decision tree programming. But it actually is a common pattern that we use today. Hopefully, with what's going on in the industry in AI, we don't get just flooded with Clippies. But really, another important point was in 2022, because Google introduced the paper that was the foundation of where we are with generative AI, but nobody really cared, right? Because nobody's reading those papers except for the people trying to implement it. It wasn't until ChatGPT releases and it gets in our hands that it becomes important, and now people take notice. The other thing that was really interesting is when Meta open sourced the Llama models. Well, you could look back and you say, well, OpenAI did have a bunch of models and they just finally released some new ones recently. But it's this idea of these models are now getting in the hands of everybody. And it really democratized the access to it so that we can actually start building complex things. All right, so with all of this, what is a model? So a model is just a general term for a machine learning algorithm that processes a large amount of data, right? Within that, we have this thing called a foundational model, and you'll hear this a lot. So this is a type of a model that's trained on a massive data set that's specific for performing certain tasks. Within a foundation model, you then get to a large language model. So this is a type that's specifically trained on text. An example of that is you hear things like GPT-4o, so generative pre-trained transformer. So this is an example of a specific implementation of a large language model. And that paper that Google wrote that started this was called Transformers. All right, congratulations, we're caught up, we got a model. But it's stuck at a point in time, it has no live data, and it knows nothing about your business. Going back to my image, right? Like it's kind of, it's there, it can do some stuff, but how do I make it valuable to me? The first thing people started to do was train the models. And they're taking, and there's multiple facets of this. There's specifically training a model for your task. There's fine-tuning one that already exists down to a specific task. But the issue with all of this is it's kind of a high barrier to entry. You gotta have very specific knowledge in order to do this. And usually those guys want a lot of money that know how to do that. So that's usually the first barrier for people. But when the Gen AI started to take flight, the first thing that people started to realize was this whole idea of prompt engineering. This is the lowest possible barrier to entry. It's just asking better questions, right? And you don't want to ask questions like, what restaurants are close to me? You want to be very specific. You want to say, what Italian restaurants are within 20 miles of me? Have vegetarian options. So you get a better opportunity for getting a response. And then within that, you can templatize. So that's really what most people are doing with prompt engineering. I'm kind of simplifying it a lot when I say just ask better questions. But what they're really doing is they're templatizing the input that they put in to make the model respond in a certain persona. And the last piece is providing your data, right? So these, since they're stuck at a point in time and have no live data, you have to figure out a way to get your business data in. And so there's been many different patterns that people follow. And this requires some software engineering, so there's a medium barrier to entry. And the most common one that everyone was talking about, and they still are, even with the world of agentic that we're in now, most people are starting out by doing retrieval augmented generation, or RAG. So that's the most common term you're going to hear out of that group of providing your data. So just remember, models are incredibly powerful, but they're like Dory. Every time they see something new, it's new to them, right? And it's all about how do you remind them on a constant basis how you're acting, how you're going to interact with the world around you. Also, you might realize that Broadcom has enabled the Gemini integration, so I have generated a lot of images in this. While we're on models, there's one other thing that's interesting you should probably know about is distillation. So distillation is another way, kind of like fine-tuning. It's where you start out with a big model and you want to make it more efficient and easier to run. And there's a couple different options out there for services that do this. OpenAI has a service, AWS has a service, but the idea is you're gonna come up with a set of conditions that you wanna match against. You're gonna start with a big model, you're gonna feed in your conditions, and it's gonna train the model from that big teacher model down into a student model that's very specific and good at one thing. The idea is you can run this on less powerful hardware, more efficient, cheaper to run. Whew, now we're at RAG, Retrieval Augmented Generation. So, does anyone know what a butter tart is? We're gonna go off track a little bit. So in Canada, butter tart is a regional kind of dessert. Easy way to think about it is imagine a pecan pie with no pecans, just the really sweet goo. And in order to eat that, they make them like this big, because no one can handle that much sugar. I have family that lives in Canada. I just went up to Toronto to hang out with Adib and go to a V-Mug there. And I was going across the border and I was like, well, how many butter tarts can I bring home? And the model, first of all, gave me a crazy answer about standard pies, and it didn't know what a butter tart is, like most people. So I had to do a little bit of prompt engineering up front. So I'm gonna say, how many butter tarts can I fit in a four-door Ford Bronco and drive from Canada to the US? So I'm asking a better question. Well, how am I actually gonna build an app to do this? So I'm gonna start out by building an application, I'm gonna need an LLM, great. But I need another type of model that we haven't got to talk about yet. I need an embedding model. So there's a whole classification of models called embedding models where they are good at looking at text, converting them into vectors so you can put them in a database. So I'm gonna build some sort of ingestion pipeline. Most of the time you're gonna hear this referred to as an ETL pipeline. And so what this is gonna do is take specific information on knowledge sources and put them in a vector database. Now when my question comes into my application, the first thing I'm gonna do is what's called a similarity search. I'm gonna take the question, so I say, hey, how many butter tarts can I fit in four-door Ford Bronco? It's gonna pull every bit of information from that database, and it's gonna allow me to put it into the prompt as I'm asking the question. So I'm trying to get, hey, model, this is a bunch of relevant information. You probably need to answer this question. So in this case, I'm gonna preload it with like specifically Ford Bronco, vehicle cargo size. What is a butter tart, the size of it, so that the model can actually understand and give me a relevant answer. And now I actually got back a pretty interesting answer, which was I can fit 3,280 standard size butter tarts in a four-door Ford Bronco as long as I pack them neatly. I specifically pulled this out of the model that I was interacting with to highlight here, but what you don't read that I cut off that was kind of funny is the model warned me that I was crossing a border and I should probably focus on bringing home quality butter tarts and not quantity. All right, so that's RAG. What is an agent? So first of all, everyone you talk to is building an agent. Every single vendor out there that has AI, they got an agent, great. But there's a vast spectrum of what they mean. What they probably mean, at least most of them, is they're building an outcome or a UX pattern. They're building Clippy, right? What we actually mean when we say agentic is, and it comes from the data science land, right, this term. It's allowing the large language model to have the agency to decide how it's gonna answer the question. So you're actually putting it on the model to come up with the pattern. And I like Hugging Face, and there's since many more that does this. They actually have a rating system of how agentic something is. Like a 1-star is it can build an if statement. 2-star actually builds functions, recursion, things like that. All right, so what's interesting from a platform team perspective is this really sounds like any other application. It is AI, we have some new things to worry about. How do you test for non-deterministic results, things like that, but it's really just software development. So here's an example. The good news is, and I want to point out Adib on this, call him out. He came up with this slide and used this example, I don't know, 6 months before all of a sudden we were all flooded with, who's it, Matthew McConaughey on Salesforce, explaining to us that Salesforce can help us book a restaurant. So, instead of asking a poor question like what restaurants can I get a reservation in, we can ask very specific things like I have a business dinner at 6 p.m., 6 people, find me a restaurant that meets my company expense policy. Well, in order to do this, what we're doing is there's a lot that happens between the lines that the model is going to interpret to solve for. Like, we need the restaurant to be within 30-minute drive to get there by 6, make sure it has vegetarian options. But what is the company expense policy? How do I look that up? So it's going to say, I need this information to make that decision. And the other one, too, that was interesting is it can think about the things that you're maybe failed to think about. Like, it's not too noisy, so I can have a conversation. This is a business dinner. We don't want to go to a comedy club. So from an application standpoint, we kind of move from traditional applications that involve apps and data. And then we go to apps, data, and we introduce the model. So this is kind of your first RAG. We call it intelligent applications. This is the first step everyone's going on. Now we get to this agentic application where behind the model, there might be many things that are needed to answer the questions. And in order to do that, there was many ways you could do that. But in November of last year, or this year actually, we're not even up to a year old on this thing, Anthropic introduces Model Context Protocol, or MCP. So this is a brand new standard that helps you build this in a consistent way so you can reuse these. And this is super important because now it's making it easier for the teams that are building the different components to interact with each other. And in my head, the easiest way to remember this is I always just read it backwards. So it's a protocol, a standard, to provide context into the model. So it tells the model what tools are available and what they do. I'm going to skip over this one. So the next bit is, all right, well, now I built this model, or this agentic piece of code application to solve a complex problem. And then somebody asks, how do I buy playoff hockey tickets? You could tell I was in Canada when I built this. The model is like, I don't know how to do that. I know how to do butter tart cargo capacity. So what is interesting is now we need a new thing, and we need to be able to build agents that are purpose-built to solve different tasks and communicate with each other. So then Google comes out with agent-to-agent protocol, and this is supposed to standardize on how these things come together. This is a really heated topic right now, and where it should be implemented. It should be part of MCP. But they'll figure it out. Everything's moving really quick in this space. All right. Congratulations, everyone. We made it through. AI 101, you're all caught up to speed. Except by the time we finish that, somebody probably already released a model that's better than the last model, and somebody figured out a new integration pattern, right? So how do we keep up? So I'm going to pass it over to Adib.
All right, so what I want to start with, since we're in this conference, is to talk about what the AI stack looks like at a logical level. Raise your hand if you've ever seen the ISO networking model with the 7 layers. Okay, and that is a mental model for how to think about networking, even though in reality, you don't see all the 7 layers and everything. They're kind of squished together in different protocols. So if we were to do the same for AI, what would that look like? Well, you have a server at the bottom. You stick a bunch of GPUs in there. And those GPUs are going to require you to get some sort of drivers. On top of that, you need to put your hardware drivers, your CUDA drivers, whatever is the equivalent of that for AMD. And that means that the developer does not have to know what particular version of the GPU am I dealing with. On top of that, you're going to need some machine learning libraries. This is where you see things like PyTorch and TensorFlow. They're libraries to help you more easily program a neural network. And once you have that, you can now use those PyTorch and TensorFlow to actually write the source code for a model. And once you have that model up and running, that's how you end up with something like Llama 3.1, then you have a model, but it kind of works on a single machine. It's not visible on the network. If you would like your application to access the model, you would need to have a way of making an HTTP call to get and access the model. That's where you start getting into what's called an inference server. You'll see open source projects like Ollama would be one of those. VLLM is another very popular one. And that exposes your model on the network. But that's still within a single host, right? What happens when you need to have multiple machines that are serving models? Well, you're going to need some sort of load balancer in front of this set of hosts that have these layers in them. And that is how you get to what we like to call model as a service. You want to get to a point where you have some sort of service that can give you a URL. When you make calls to that URL, you end up getting routed to the right model. And hopefully this is helping you build a mental model of the different layers. Now, there's another thing now on top of this, which is what I like to call AI middleware. And that's the thing that connects this model as a service into the application world. Because it's not enough, like a model running inside of a service isn't going to make you money. It's not an agent. It's not an app. So you need an application runtime to deploy your agent into. And then your agent is going to need a database to store its data, and a vector database or a message queue or a cache. So you need a marketplace of services. And then you need to deploy the code and probably need to create a container out of it. You need to compile it. You need to add monitoring agents and all that. So you need some developer services. And that combination at the top is what I like to call an application platform. So hopefully this gives you a bit of a mental model. Again, think of this as the way you think of the ISO 7-layer networking model. It is a conceptual way to think about the world, and it helps you kind of understand where you play, okay? So if you are more of an infrastructure person, you're going to be concerned with the lower layers of how do you get those drivers installed and how do you deploy the models and lifecycle them. If you're more of an app developer, you're going to be concerned with the stuff that happens in the application platform. So that kind of is a good lead up for Tanzu, because Tanzu is an application platform, right? And so our mission is to basically make it really easy to accelerate from idea to production. And within the Tanzu platform, there are a bunch of key things. Number one is that it works everywhere, private cloud, public cloud. Number two is it has a bunch of developer services, build service, data services built in, databases, message queues, all that type of stuff. We have AI solutions that we're talking about today, and you have a marketplace where you can access things. And the goal is that the platform team can offer a turnkey solution to the developers. So the developers just show up and they're able to focus on building their agents and writing their apps. And whatever they do is within the guardrails of the platform. They don't have to say, is this approved or not approved? If you want more of a traditional look at it, this is where you kind of see the layers of where you have like virtual infrastructure on the left, and then you have infrastructure as a service, then you have platform as a service. The right-hand side is platform as a service, and that is really what Tanzu Platform is. And one of the interesting things that's happening today is that people are using coding agents, but people are also using SRE agents. Anybody got an SRE agent? An agent that's controlling, running around in production, doing stuff for you? More of you will in the future. I have no question about it. And so platform as a service is a lot easier for an agent to manage than any lower level layer, because it is much more opinionated in what it does. So now I want to talk a little bit about the AI services that are part of the Tanzu platform. And so our goal is to basically make it safe and easy for you to build apps. And so looking at this diagram over here, you can see in the middle, there's that little box that says AI middleware. And that AI middleware is sitting between the applications and the models and the databases. And so the goal is, how do we reduce the effort required to build an application? If you have one application that you're building, you can just build it. Like, there's nothing to worry about. But if you're an enterprise and you have 100 applications, you find that people are having to cut and paste code from one app to the next to the next. And then each app needs to go through a process of checking, did you follow the company procedures? Are you secure? Blah, blah, blah. And that becomes a bit of a problem. And so let's dig into the details of what this AI middleware can do for you. I'm going to skip over this one. And I think I already covered that. Okay. So the key thing we want is centralized policy enforcement point. If you're able to send all of the interactions between the apps and the models through a choke point, which is the AI middleware, you have one place where you can enforce policy. Well, what kind of policy do you want to enforce? There's a few. The first type is security policy. For example, you want to make sure that each application has its own unique API key, which is independent of where the model is actually running. So maybe you have a bunch of GPUs and in your data center, and you're sharing those models with many different applications, and you want to say application A can access this model on that GPU. And that allows you to have keys that are revocable. So if all of a sudden you get reports that your app has gone crazy and it's telling people to do dumb things, like it's telling them that the price is $0 for your product, you could like revoke its API key and like stop it from accessing the model, which keeps other functionality going, but doesn't cause your app to die. Another thing you can do is consumption policy. AI, everybody's worried about the cost, right? The cost in terms of electricity consumption, the cost in terms of dollars, and the unit of consumption is the tokens, the AI tokens, input tokens, output tokens. That means that it's really critical that you're able to set policy on token per minute rate limits. Application A is allowed to use 100 tokens per minute. Application B is allowed to use 1,000. Also, requests per minute. Sometimes tokens per minute isn't enough. You need to basically, because a single request could consume a lot of tokens. So we give you the ability to do both. And then, of course, you want to be able to bring your own policy. That policy could be things like that are somewhat unique to your business requirements. And that could be like, we don't know what those policies are. Like take content safety as an example, right? We don't know what content safety API your company has approved. And so using this, you're able to, as the requests travel through the middleware, they get sent to your content policy service, they come back transformed, and that's what the model sees. So things like PII and other stuff are things that this approach enables you to do. The next thing that everybody wants is to know what are these things doing. Again, because you're going through this AI middleware, you're able to have a way to transparently collect metrics without having to install any kind of monitoring agents. You don't have to change the source code of the application. What happens is that your requests flow through there, and we emit metrics using the industry standard like OpenTelemetry semantic conventions for Gen AI applications. And that means you can use this with your existing observability solution. So if you happen to use a product that you like, let's say you're using Grafana for your dashboards, you get to use that. If you're using Splunk, you get to continue using that. We don't really care what specific observability tool you're using. We just want to make sure that all the relevant metrics, logs, and traces related to AI and what the AI applications are doing get to the place where you normally look for stuff. Because let's be honest, raise your hand if you want another dashboard in your life. I don't see any hands up, right? You want insights, not dashboards. The next item is a little bit of like, okay, we want to be able to do flexible routing. What does that mean? That means that you don't know if a new model shows up tomorrow that might be faster, cheaper, better. But is your application going to work with that model? By having this AI middleware from Tanzu, you're able to change your configuration settings and you can direct the request to this new model. But you don't yet trust this model, right? So what you want to be able to do is to really say, every request that comes in, send out two. Send it to the new thing and the existing thing. And I want to record those in a journal so that I can then download how did the models respond for these different application requests and perform some analysis. Like one of the roles where this is really useful is that you have a lot of companies, we see that they have data scientists, data engineers, and I call them AI gurus, like people who really understand these models and how they work, and they have opinions about what's the right thing to do, what's the right price, performance, governance, all of that. By having this model interaction journal, you're able to allow those experts, who are very few in a company, typically 5 people or less, are then able to study and see how are the applications doing in the real world, and they can make recommendations and change configuration settings based on that. So this way you don't end up having this small group of people become a bottleneck, and you don't end up with the developers just going wild and doing stuff in a non-controlled manner. So I hope you see how with this AI middleware, we enable you to have a simple path to production for developers, because developers show up inside the Tanzu platform, they're able to find the models, they're able to find the data services they need. You can accelerate tuning for AI models for your data scientists, because you give them a place where they don't have to have the apps architected a certain way to get what they need, and you get the governance that the platform team is able to offer guarantees about what is happening from cost, performance, and other kind of technical concerns. Any questions so far? Okay. So the last piece is a bit more of an app-level kind of mental model, is that in order for you to be able to make an ROI off of an investment in AI, you need to get that AI into the applications that your customers are using or your employees are using. And that's an integration problem, because you have a lot of data in your existing databases, you gotta get to the models, and you already have a lot of APIs that your organization has built over the last 10, 15 years. And those APIs contain a lot of valuable data that you might need to selectively make available to the platform, to the models, and that's an integration problem. And us in Tanzu, well, we happen to own a thing called the Spring Framework, which is like 20 years old and knows how to do this problem incredibly well for enterprise scenarios. So what's the Tanzu approach to AI? I would basically say it's just another, AI models are just another service on the platform. Vector stores, they're just another data service on the platform. RAG knowledge bases, they're just another application deployed on the platform. AI agents, they're just another application deployed on the platform. There isn't really, you can take an existing platform as a service, like Tanzu platform, and you can turn that into, it's a great place for running these agentic workloads. That gives you standards and speed and safety. Because it has standardized interfaces, developers can't just go off and do unique things. They're kind of following the guardrails that the platform gives. We have support for the Model Context Protocol, like you can easily deploy your MCP servers on there. And our AI middleware, I forgot to mention it, when you talk to it using the OpenAI API. So my code that I write and deploy, maybe I deploy a Python app, it uses OpenAI's client libraries, it talks to the AI middleware, and that will then convert it to a GCP Vertex call, or that will convert it into a Bedrock, AWS Bedrock, or Azure OpenAI, or OpenAI, or some other thing that might be of interest to you. And it's really all about that optimal relationship between devs and operators. Turn it back to John.
We talked for so long, I got locked out. Shit demo. All right, so we wanted to work through, showed you a bunch of slides, give you a lot of terms. What does it practically mean? So first of all, this is Explore. I always like to talk about home labs. So I'm running this whole thing in my home lab. And if you want to know how much infrastructure you need to test this, I'm running it on a mini PC this big. But then we just talked about GPUs, so I cheat a little bit. And I have a gaming machine sitting on my home network that has GPU. So when I'm not on that, I call from this model brokering that comes through the AI middleware. So let me get this started. And I'll keep talking. But the other thing too, it only has 96 gigs of RAM, but I'm running the memory tiering. So if you haven't played with that for your home lab, so I have an extra NVMe drive stuffed in there, so it thinks it's more RAM. So this little tiny box this big has 463 gigs of RAM that it thinks it has, and it works fantastic. So that was a tech preview in vSphere 8 Update 3, went GA in 9.0. And then you can see I've deployed a lot of stuff. So it takes quite a bit to get this up and running. But we, as part of the show, we released we call it the Tanzu AI Starter Kit, and there's a Power CLI script that will automate the install of this onto vSphere. But what do you need? You need the overall wrapper that I've logged into. This is the OVA that gets deployed for Tanzu Operations Manager. And from there, to add new functionality to the platform, you deploy these things called tiles. We have the VMware Postgres tile. So this is actually how I'm going to get my vector DBs. So by deploying this, it enables me as a platform engineer, and that's this view here, this is the platform engineer view, to give self-service access to models, or I'm sorry, Postgres databases. And then the Gen AI tile that we're talking about allows me to give self-service access to models. So what it's showing here is, out of the box, we give you a way to deploy models based on Ollama or VLLM. So this allows you to deploy CPU-based models. So these 3 models that I'm showing here, I've configured, and it deploys them within my little vSphere environment on my mini PC. What's really interesting is we're seeing a lot of success with customers who want to get started with an AI, and they think there's a decision tree that has to happen of, do I let my data go to the public cloud, or do I got to make an investment in GPUs right now? And our view is that you can get started now with your CPU models. They're going to be slow, not going to have the best outcome if you're running small models. But at the same time, it's a way to get started and validate you have a use case before you make an investment in GPUs. So what I'm showing here is just how the configuration happens. The model URL I'm showing here, by default, we just pull these off of the Ollama registry or the VLLM off of Hugging Face. But here, if you're in an air-gapped environment, I can go through and I can override and deploy local models that I've put in my own repository. And then I'm just going to configure where it runs. So in that case, I gave it a VM type of CPU. So it's just going to deploy a VM for me in the background. Now, the other thing here, I'll go to in a minute, is skipping ahead to save time. The integrations. So we have integrations with basically every single SaaS-based model provider. So the key takeaway here is we don't care where you get your models from. They're going to come from somewhere. You're going to have an opinion about that. We want to make it super easy for the developers to consume them. So this is where I'm cheating on my home network, is I have OpenAI compatible models. So these are network accessible models. So if you look down here, I'm just calling out on my home network to, this is my Windows box running Ollama. But this could be pointing to OpenAI's website. You can point right to ChatGPT if you want. So we support all those. So what I've done now is I've configured where I get my models from. Well, now I need to configure how my developer will get access to them. Oh, and very important point, we have VMware Private AI here too. So we can help you deploy models on CPU and stuff, but if you want to go further, you can integrate and use VMware Private AI for the core model hosting, and we're providing that PaaS experience, that developer experience on top. So how do I then convert that to a developer consumption is by creating a plan. And you can do things like create specific plans, like this one is the chat model. So you can abstract away from the developer what model it is, because do they really care? They just need to know that it's a chat model. Or you can do things like build use case driven plans. So in this case, I have dev chat. And what is happening here is I'm actually giving a combination of things. So I'm going to give you your embedding model, your chat model, so you have everything you need in one consistent endpoint that you can interact with. So this dramatically simplifies the interaction because the developer only has to, configure one library to work with an OpenAI compatible backend. So we don't care what programming language you use. You just need a library that can talk OpenAI. And then I can build these plans that are specific to a use case. So here I'm just creating a specific plan for that little model I just added. So the model, I think it was Gemma, just released a super small one that's made for running on phones, and I just wanted to see what that actually could do. So this is now the developer experience. So when I log into this interface, and everything we can do here, we can do through the CLI. Most developers are going to do it through the CLI, but CLI doesn't demo as well as the UI. So when I go in here and I go to the marketplace, I find, hey, there's these Gen AI on Tanzu Platform. And this is where the developer can see and get access to those plans. And so right here, just for a quick, did I set everything up properly? I'm going to deploy, or I already deployed Open Web UI. And I grabbed the model on the back end with the plan, this model playground. And then I'm going to go to Open Web UI, and I'm using the GPT OSS model that was just released a couple weeks ago. I'm just going to verify it worked. So in order to do this, all I really had to do was go download the Open Web UI source code, and then I used the developer experience to push it onto the platform, and then I bound it to the model. And because I did that, it automatically showed up in the interface, and now I got access to a chatbot, right? Basic chatbot. Well, that's great. What about if we want to actually build one ourselves? So first thing I'm going to do is, well, I'm going to back up a little bit. I'm going to pause here. First thing I'm going to do is I need to write some code. Or if it's the last week before Explore, you go to Corby's website on GitHub and you download his. And so I did that. And I'm going to get it on my, downloaded it, I checked it out from Git, and now I'm going to do a CF push. So this is how the developer interacts with our platform. The CF push makes it dead simple to push applications into the platform. And when I do this, now I just have an application running. There's no model involved yet. So I need to get myself access to a model. I'm going to skip ahead. All right. So I'm going to log into that developer experience that I just showed. And there's two ways to do it. There's the marketplace integration that I just showed, but I can also go directly to the application. So because I pushed that application onto the platform, I was able to go directly to the application object and then in context pick a service. So that got me access to that same marketplace. So I found the Gen AI one, I picked the model that I want, and now I'm restarting it. Because I bound it in the interface, it actually, on the back end, is creating a relationship between the newly created endpoint and the application. And when by restarting it, it's going to pick up that configuration change. And so now I actually have an application running with a large language model. So I'm going to go through and just validate that really quickly. But the point here is that I'm now at that point where I have a model, but it's stuck in a point in time and it knows nothing like about my business or anything like that. Well, how do I move from having a basic model that just can provide a basic interaction to being something more relevant? So I'm going to get it to write Python for me now. So the next step is there's two things I need. One is I need an embedding model. So we want to do RAG now. So I'm going to need an embedding model. And so I go in here, same flow as before. I find it in the marketplace, I bind it to my application, and the other thing I need is a vector database. So because I had that Postgres style available, I can go to the marketplace, I can find the Postgres database, and I can provision myself an instance. For the sake of the demo, I provision the database ahead of time because it takes a little bit longer, a few minutes to do. But here you can see that I'm binding the database to the application. So now I have a running application, I have a language model bound to it, I have an embedding model bound to it, and now I have a database that can access bound to it. And if you notice, there was no code changes here because it can pick up the configuration that is being dictated through the PaaS platform. So it's really a simplified experience. So I'm restarting again just to pick up those changes. So now I'm going to access it again, and I skipped right to the answer. Come on. I went back too far. All right. So now that I have all that there, I need to provide some context. So I went and grabbed the security outcomes with VMware Tanzu Platform white paper off the internet. And this seems like a super relevant tool because I don't know how many white papers I get sent that I don't really want to read, but I do want to know what's in there. And so I grabbed that and I used the web interface to upload that. And so this application is actually taking anything that's fed to it and uploaded, and it built a little pipeline, and it's embedding that into a vector database. So now this same large language model that I'm using has direct access to the vector database. So it's doing the similarity search up front, and now I'm actually getting a summarization of that specific document. So now we went from model, kind of dumb, added some RAG, now we got some information. Well, how do we go from RAG to agentic? Well, in order to go to agentic, we now need an MCP server. So you can go out, you can find one on the internet. There's a lot of them out there. There's a lot of registries out there. But we had one that was developed in-house. And so what I'm going to do is bind to that. So right now, there's kind of a little cooking show thing happening, which is behind the scenes, I already went and pushed the MCP server just like I would any other MCP server, or any other application, just like the client application that I pushed here. And then I bound it to, or I created a user-defined instance of the service, and now it showed up in here so I can bind to that user-provided service. So this is one of the things we're looking to improve in our next release, is making this more of an integrated experience. But I follow the same flow now. I just restart the app. And so now it's going to pick up the configuration of that MCP server. So if I look over here in the application, I have a model. It's showing what it's bound to. You got the vector store, everything. And now I have this MCP server, and now it's showing me the available tools. So this one is the Cloud Foundry MCP server. So this is actually building an SRE agent. So now I can use this same chatbot to talk to the platform that this is actually deployed on. So now I can ask a question specifically about my platform. So in this case, what spaces do I have access to in the current foundation? So this is inquiring into the existing platform. All right, so now you're going to see that I'm getting a whole list of spaces that are available. All right, we're exactly at time. Does anyone have any questions in the final moments? Set up what? KV cache? We don't support that today, but that was just asked by one of the customers too.
So the KV cache would be depending on which hosting engine you're using. So we're offering VLLM, which has a built-in KV cache, and we're offering Ollama. Ollama is based on Llama CPP. They have their own version of that. But really our focus in Tanzu Platform is on the developer experience and how to offer a consistent way to access these models while allowing the platform engineers to optimize how they'll run under the covers. Sorry? Like KV cache, do you mean like key value cache like Redis, or do you mean like KV, like cache inside of the inference engine?
Yeah, in your demo, you showed how to set up a rack using Postgres. So I can select the database type. So KV cache, you don't have any.
Like if you're, okay, I'm trying to,
Do we support KV cache from the services marketplace?
Like a key value, yes, we have support for Redis, we have support for Gemfire. The answer is yes. If you want just a database, like a regular application level cache, we absolutely have that. I misinterpreted your question as the KV cache that's built into the inference engines like VLLM.
And I did the same thing.
Sorry,
we just had a customer asking. Yes. Yeah, we just did it.
Yeah, sorry.
Anything else?
I had a question on, so when you built your platform, your lab, and I apologize if I missed it, do you need VCF, or can you just download the Tanzu platform and run that?
It has to run on vSphere. So vCenter is deployed, and I'm interacting and deployed it all through vCenter. Because the core Bosch director, there's a tile in there called the Bosch director for vSphere. And what that's doing is it's providing all the automation layer that we're going to use, and that's where you put in your vSphere credentials and all that stuff here to log into vCenter.
Yeah, but do you need VCF or like just vSphere?
You just vSphere. Yeah.
From a platform perspective, if you want to like task or give data or demo work for customers, this run theoretically sounds something that would run on like a higher end laptop that you had enough let's say if you had an AV 3000 RPX and AV 3000 on a laptop, memory should run on that.
Yeah, I mean, if you spun up an ESX host and you had vCenter running on it nested, sure. Like in theory, yeah.
Yeah, which part do you want to run on this machine? Like the models or the platform itself?
No. We actually had in the past a local deployment that would run on a laptop, but it was more for basic sales demos and stuff like that. But I mean, in theory, you could make it work, but it probably wouldn't be too practical.
Yeah, like out of the box, it's not tuned for running on a single thing. Yeah.
But you don't need it, and that was the point of showing this, is you don't need a ton of resources. So like if you guys wanted to try it in your vSphere instance, you don't have to dedicate. Yeah.
Like for a lot of the stuff for demo purposes, especially the AI pieces, is you can actually access it off platform. So the developers would go into that marketplace that you saw, but there's a feature there called create service key. So what they would do is they would create a service key, which when they look at it would give them a URL that they can copy and paste into their app, and an API key that comes from the platform. And so that's how you would give them access to on their dev laptops. It would talk to the platform for real. Does that make sense? Yeah. That goes for a lot of the other services in the marketplace. There's an ability to access them from your development machine.
Sure.
So yeah, during the morning session, I saw the virtual GPU names.
Yep.
So your framework also connect to that GPU
Yep.
names.
We're not doing anything directly like plugging into the management layer. We're literally like sitting above, giving that platform experience. So like if you have a platform that you can take advantage of eGPU, that's a great place to run this on top. But we really want to focus on that, giving the developer experience.
Yeah. Like remember on the chart we had like model as a service, and we had application platform. So our focus is more on the application platform part. There are a lot of different model as a service offerings out there. You can definitely get them from the public cloud, like all the cloud providers, Anthropic, OpenAI. There's also multiple different offerings in the private cloud world, like VMware Private AI Foundation. You can definitely do stuff on ours. Our goal is really the app platform and the developer experience and the platform engineer experience. And you pick whatever model as a service you like.
All right. Well, everyone, thanks for showing up. Thanks for taking your time out of your day. And please take the survey.